We're going to be discussing inverse functions. And here's the big thing. A function must be one-to-one to have an inverse function. And the reason for that is simply this. We have, let's say, the domain of and this is going to be the range of f. And f carries something from here to here. So that's what f does. F inverse, or the inverse function of f, is going to take something from here and take it back to the domain, meaning that this is the domain of f inverse. This is the range of f inverse. So the reason that the function has to be one-to-one for an inverse function to exist is because the range became the domain. And that's going to be something that's going to actually help us out in a little bit. Let's look at an example. And yes, I know this again says the following functions. One of them is not up here yet. So here I have this as my function. I can verify that it's one-to-one because 1, 2, 3, and 4 each appear once, so it is a function. And 5, 8, 11, and 14 each appear once. So let's think about what the inverse function did. It takes my x and y, and it's going to map that on to y comma x. So my inverse function of this is quite literally the set 5, 1, 8, 2, 11, 3, and 14, 4. All right, so there's our inverse function for that. Now for our second example, let's say that we have A, B, C, D, and then over here we have 1, 2, 3, 4. I'm being incredibly inventive. A will go to 2, B will go to 3, C will go to 1, and D will go to 4. This clearly represents a function. Each of these only occurs once, or it only goes to one item in the range, and these range values all appear exactly once. The inverse function is going to take 1 to C, 2 to A, 3 to B, and 4 to D. So this is my original function, and this is the inverse function. All right, so those are two ways of kind of looking at it. Let's move forward one. And here we're going to find the inverse function of an equation. Now, this function is one-to-one. So how are we going to go about finding the inverse function? Well, this is essentially y equals 2x minus 1 over x plus 1. And of course, x cannot be 1. I want to know the inverse function. So one way that we can do the algebraic work is to set this up as x equals 2y minus 1 over y plus 1. Now, I'll be honest with you, I prefer denoting it as y inverse, because this and this are not the same thing. But for the purposes of finding what it is, we don't really have to have that. So we have this. Okay. We want to get y by itself. We want to solve for y. So the first thing that I'm going to do is I'm going to multiply both sides by y plus 1, and that's going to give me x parentheses y plus 1 equals 2y minus 1. And I'm going to also go ahead and distribute this x to give me xy plus x equals 2y minus 1. Now at this point, I'm going to add 1 to both sides, and I'm going to subtract xy from both sides. And the reason that I'm doing this is simply because I want to get everything that has a y onto one side of my equation, and everything that has an x onto the other. And I just chose to go this route. So, on my left-hand side, I now have x plus 1. On my right-hand side, I now have 2y minus xy. Hopefully you see what I am about to do. Excuse me. I'm going to factor out a y. And that's going to leave me with x plus 1 equals 2 minus x times y. And then I'm going to divide everything by 2 minus x. What happens? I end up with y equals x plus 1 over 2 minus x. This is my inverse function. We just need to make sure we write it in function notation. So, my inverse function with regard to x is x plus 1 over 2 minus x. Alright, that will do it for this video, and I will see you in the next